Hello everyone, welcome to Den Talks. So today we are here with another video for you. If you are new to the channel, do subscribe to the channel and hit that bell icon so you never miss an update. In this video, we will look at how 6th generation wireless technology will be an improvement in the technical world. 6G, 6th generation wireless, is the successor of 5G cellular technology. 6G networks would be able to use higher speeds and have much more bandwidth and reduced latency than 5G networks. One of the 6G internet targets would be to enable communications with a latency of 1 microsecond, which is 1,000 times quicker, or 1/1000th the latency than 1 millisecond throughput. The demand for 6G technology is expected to allow significant advancements in imaging, presence technology, and location awareness. The computational architecture of 6G would be able to autonomously decide the best place for computing, including decisions about data collection, encoding and distribution, thanks to artificial intelligence, AI. Now let's look at the advantages of 6G technology over 5G technology and see if the former is better. 6G is expected to accommodate 1 terabyte per second data speeds. This level of capacity would be unparalleled, allowing 5G systems to work better but still extending the reach of technologies to serve increasingly modern and creative applications in the areas of wireless communication, cognition, sensing, and imaging. The higher frequencies of 6G would allow much faster sampling speeds, as well as much higher throughput and data rates. The use of frequency selectivity to assess relative electromagnetic absorption rates in conjunction with sub-mm wave is expected to lead to major advancements in wireless sensing technologies. Furthermore, though mobile edge computing is being seen as a possible extension to 5G networks, it would be integrated into all 6G networks. By the time 6G networks are implemented, edge and core computing can be much more seamlessly interconnected as part of a hybrid computation technology architecture. When 6G infrastructure becomes operational, this will have a number of possible benefits, including increased access to artificial intelligence, AI capabilities. 6G is expected to be publicly available in 2030. 6G is being built in response to the need to take advantage of the terahertz spectrum to expand bandwidth, lower latency, and boost spectrum sharing performance in an increasingly dispersed radio access network. Though there have been some preliminary talks to identify 6G, research and development began in 2020. Many of the issues of millimeter wave radio deployment for 5G new radio are supposed to be resolved in time for network designers to tackle the complexities of 6G. 6G wireless sensing systems are expected to use a variety of frequencies to determine absorption and change frequencies as required. Since atoms and molecules emit and absorb electromagnetic radiation at specific wavelengths, and the emission and absorption frequencies of any given material are the same, this is true. Many government and industry applications in public safety and sensitive asset security, such as threat identification, health control, feature and face recognition, decision-making in fields such as law enforcement and social credit schemes, air quality assessments, and gas and toxicity sensing, would be significantly impacted by 6G. Improvements in these areas will also allow for advancements in new technologies such as smart cities, self-driving cars, and virtual reality. The 6th generation of wireless networks will incorporate a range of historically disparate innovations such as deep learning and big data analytics, rather than ever before. All of this integration would be facilitated by the advent of 5G. The need for edge computing to maintain maximum throughput and low latency for ultra-reliable, low-latency communications solutions, as well as the need to enable machine-to-machine connectivity, are also critical drivers for 6G. Furthermore, a close link between future 6G solutions and high-performance computing has been discovered. Although some of the data from mobile devices will be processed by edge computing services, the majority of it will be processed by more centralized HPC resources. The term beyond 4G was coined a few years ago to describe the desire to go beyond what was previously imagined as part of the progression of 4G with the LTE standard. Since it was unclear what 5G would mean at the time and only pre-standards R&D stage experiments were in the process, the term B4G was coined to refer to what was feasible and theoretically usable beyond 4G. Ironically, the LTE standard is still evolving, with some parts of it being included in 5G. B5G, like B4G, should be seen as a stepping stone to 6G technology, which would make 5th generation capabilities and 5G implementations obsolete. Many private wireless applications involving evolved LTE, 5G, and edge computing for business and industrial customers are one way that 5G is paving the foundations for 6G solutions. In the same way as photovoltaic PV solar power has engendered cogeneration within the smart grid, next-generation 6G broadband networks will take things a step forward through a web of telecom services, all of which will be self-providers. 6G radio networks will have the networking and data collection capabilities needed to collect data, but the 6G technology industry as a whole will need a systems approach that includes data processing, artificial intelligence, and next-generation computing capabilities via HPC and quantum computing. This was it for today's video. I hope you liked this video. Do let us know in the comments below what you think about the 6th generation wireless technology. Don't forget to give it a thumbs up and share it among your friends. Subscribe to the channel and ring that bell so you don't miss a new video.